This is the video for Prep Packet Unit 4, Chapter 9.1. This is an introduction, and we're going to be talking about exponents and roots. So I want you to just sort of think about this, that in the past, we've learned that math is all about putting small things together and taking big things apart. And a long time ago, you learned that you could add things together to make something bigger, and we broke them apart by subtracting. The next thing we learned when we were a little older was how to multiply stuff. And you would say, I have something that's 2 by 3, which gave me 6. And you can undo multiplication by using division. And finally, we learned to build things up by using super multiplication, which is exponents. And that would be the idea of 5 times 5 is 25, or 5 to the second, because there's 1 5 and 2 5s, there's the 2, makes 25. And we reverse, and this is really important, we reverse the process by taking the root of a number. Okay? So I could have 125. And if I asked you to take the cube root, cube is 3, that would be the same as saying 5 times 5 times 5, or 5 to the third equals 125. So here's a little graphic to help you think about it. We start with the small thing, the root, and we raise a root by a power to get a larger value. So again, I might start with 2, and I could raise it to the third power, and I would get 8. It works the opposite way. You can have a value, and you can take the root of that value and go from big to small. So like on the last slide, I went from 125 was the big value. I took the cube root. I figured out what number times itself 3 times makes 125, and 5 to the third equals 125, so the cube root of that would be just 5 by itself. Sometimes people wonder, why do you say squared? Well, it goes back to geometry. And remember, we find the area of a square by multiplying the measure of one side by the measure of the other. And the area of the square is S times S, right? Side times side. Or, how many S's? There's 2 of them. Side squared. And because of that, we say squared. And it works the same way with cubed. If I have a cube, let's see if I can draw one. Not great, but you get the idea. Where the square had 2 dimensions, side by side, the cube has 3 dimensions, because it has side by side by side. So that would be the volume, would be the sides cubed. Oh, a cube is 3-dimensional. Anyway, so we've worked really hard to build stuff up so you understand the idea of finding the area from the side times side gives me area. But sometimes you start out with area and you have to figure out what the side is. So here, let's say the area is 16 units. I'm going to ask myself, what number times itself makes 16? And you can use a multiplication chart to figure that out. Find 16 and then find the number. Oh, there's a 4 and there's a 4. So that tells me that 16 is a perfect square whose root is 4. So if I were going to ask myself, this is a square whose area is 4, or 16, that means the sides are 4 each, because 4 squared, or 4 times 4, equals 16. Let's just do a quick practice. This is on your prep packet. I just want to talk about this, and a lot of it is just to sort of refresh your memory. I'm sure you already know how to do this. So let's take a look at this. This is 1 squared, so 1 times 1 is 1. 4 squared is 16, because 4 times 4 is 16. 6 times 6 is 36. 9 squared, 9 times 9 is 81. 15 squared. A lot of times we don't know our 15 times tables, but as you do more of this, you'll know that that's 225. Now, pay attention, because now this is cubing, taking it by itself. So that's 2 times 2 times 2 is 8. 3 times 3 times 3, 3 cubed is 27. 5 cubed would be 5 times 5 is 25, and 25 times 5 is 125. And what I want you to think of, and I know this sounds kind of basic, but I want you to remember you're going from something small to something big. Okay, so we're growing the numbers. It works the other way. The inverse would be taking the root. And in this case, these first few, this is called the radical sign, and I'll talk about that in a little bit. But when I see this, it means what number times itself makes 1? Well, that would be 1. And what number times itself makes 16? Well, that would be 4. 36 would be 6. The square root of 81 is 9. The square root of 225 is 15. And now pay attention, these are cube roots. What number times itself 3 times makes 8? And that would be 2. Same here, what number times itself 3 times would be 27? And that would be 3. And again, times itself 3 times. So I'm not saying 3 times 5, I'm saying 5 times 5 times 5. What number times itself 3 times. So the cube root of 125 is 5. And again, I've gone from big to small each time. So 81 was big, I took it down to 9. 9 was small, I took it up to 81. So go ahead and stop and copy, and I'll see you on the next video.